Hello students, we are here with a new topic that is very important in the point of view of exam. If you see it, and you will find the topic that the conservation of angular momentum, and it's my name Harimohan Singh, or in the student call me by HM sir, and that's a very important topic we have to understand. When we are talking about the conservation of angular momentum, there are few applications we will see about it, and we will try to solve different type of problem that generally asked in an exam, and that type of problem you will see that already asked, and in the coming years also you will see that kind of problems. So try to focus and try to learn the topics, okay, and on the board you will understand many things. Now the very first thing I'm just doing the first thing, what is the definition of angular momentum? That the property of any rotating body given by the moment of inertia times the angular velocity. If we start from scratch, if we know the second chapter, that the laws of motion, that is the important one, and after kinematics, and in this chapter we already know the few things, the what is the force, what is the F equal to ma, and similarly in the kinematics we know the very important part, that is equal to m into v, that is the linear momentum. If particle is having the, suppose this mass is having mass m and it is moving with velocity v, so we can say it is having a one momentum p is equal to m into v. That is a very simple thing, we can write it, that the linear momentum. Similarly, when analogous to this part, we call it angular momentum. What is the meaning of angular momentum? Suppose one particle is rotating in this circle, okay. If you see this radius of this circle is r, and this particle is moving with the velocity v and having mass m, so we can define its angular momentum. And the very important part about this angular momentum, we can say L is equal to m into v into r. And if we go for its vector form, you will understand we are writing that L is equal to r cross p. We define it r cross p. R is the radial vector and the p is the momentum. We are talking about the p is the momentum. Then we can say L is equal to r, that the m cross v. So we can define L is equal to m r cross v. That is the one way to write it. That the first thing you can write it, or like this you can write, or I can say angular momentum is nothing else I into omega. That's the another way to write the angular momentum. What is this I? I is the moment of inertia. We call it moment of inertia. And we talk about when omega is nothing else angular velocity. That's the angular velocity. So when we are talking about that angular momentum, I into omega also I can write, and or I can say r cross p if we know the linear momentum, we know the radial vector. From that also we can calculate. If we know mass, we know radial vector, we know the velocity, linear velocity, then also it can be calculated. This is a basic way to write the angular momentum. Up to this thing we have to understand first. I think all of you are understanding, because this is a basic part of the angular momentum. Okay, now we are going to coming to the conservation of angular momentum, where it is conserved. So we have to learn about that conservation of angular momentum. So let's see. So in this part you will understand one very basic part, the conservation of angular momentum. When we are writing conservation of angular momentum, so you will say that angular momentum should remain constant with the time. Why it remains constant? So we have to understand very simple, that L we know that is equal to I into omega, or I can say r cross p, in whatever form I can write, it both is equally correct. So we want this should not change with time. That means dl over dt should be equal to 0. That is the must condition for this conservation of angular momentum. dl by dt is 0. If we put the value, we will understand its basic part, that d over dt of r cross p, or you can write, when you open it, you will understand this dr over dt cross p first term, and the second term would be r cross dp over dt. Very basic. So from here you can say this is dl over dt, we are writing it, that is equal to dr over dt. We know the dr over dt is nothing else velocity, that the v, and momentum is nothing else m into v again. This is the first term, and the second term would be r cross dp by dt, everyone know that is equal to force, dp by dt. So what I have substituted here, the one thing we have substituted, r, that v is equal to dr over dt, one thing we substitute, and the second term, that dp over dt is nothing else force, that we already know this. So if we are putting on this, that dl over dt is nothing else, that is equal to first term v cross m into v, and plus you can say r cross f. The very first thing, I am just repeating the same line so that everyone can understand this line. Now focus on this line. Now everyone should understand what they have written, that v cross v, if their vectors are equal, so we know that their cross product would be equal to 0. So v cross v would be equal to 0, first thing. And second thing, r cross f, we define new vector that is equal to torque tau. So from here I can say that dl over dt is equal to 0 plus torque, or we can say torque is nothing else dl over dt. This is the condition, but as we have already said, dl by dt is the must condition for the conservation of angular momentum. That means torque should be equal to 0, because torque is equal to dl over dt, and that must be equal to 0. That means we can say the torque acting on a body or system should be 0, then only we can say angular momentum remain conserved. To focus in this part, our concern, today's class is concerned only those type of problem, only those type of cases in which the net torque acting on a body or system is equal to 0. That means our concerned area is this only. So that's why I start from basic. I'll just tell you, try to focus. In the previous slide, I told you the very basic thing. If you see it, what is the momentum? Momentum, I told you that the particle is moving on a circular body or any path. In that, we can define the basic L is equal to mvr or L is equal to r cross p. Try to focus. Or we can say L is equal to m r cross v, or we can say L is equal to I omega. Omega is also vector quantity. We have to understand that is the angular velocity. After that, we have defined first angular momentum. Then we focus on what is the meaning of conservation of angular momentum. So for that, we have to understand what is the rate of change of angular momentum first. So for rate of change of angular momentum, we define for the conservation of angular momentum, this is the must condition. If we focus, this is the must condition. Okay, we have studied this part. Must condition, that means dl over dt should be equal to 0. If it is 0, that means from here we have derived that torque would be equal to 0. That means acting on a body or system, if torque is 0, then only we can say angular momentum conserved. Now what we have written, L is equal to r cross p, and from that we differentiate, we open this thing, we can say dr over dt cross p plus r cross dp over dt. Everyone know dr over dt is velocity, okay, and dp by dt is the force. and V cross V, because the same vector, they are doing cross product, that becomes 0. Everyone know this part, and from that you will find this first term becomes 0. The second term is nothing else R cross F, that is the torque. If I tell you one very simple thing about this torque, we call this as a actually rotational analog of force. Just like angular momentum is the rotational analog of linear momentum, similarly this torque is also rotational analog of force. And one more term we are writing here, I. What is that I? I is the moment of inertia. It is also rotational analog of inertia, that we call mass. Mass is the actually inertia of translational motion. Similarly, you will see in rotation, actually I is the analog of the rotation, okay, inertia. And I define a mr square. I mr square for a single particle. If another body, we already know about the I, moment of inertia. So now we will use it. We will see some examples. You will understand by examples one by one. The most of the example I actually collected from previous year, from different exam. Some exams maybe Neet or maybe JEE band and JEE advanced. Different exams I have collected. So you will find the similar type of problem in PYQs also, to try to learn those questions. Okay. Now the very first example, a round disk of moment of inertia I1 and about its axis perpendicular to its plane and passing through its center is placed over another disk, the second disk, and having moment of inertia I2 rotating with the angular velocity omega about the same axis. That means I1 is not rotating. The second disk is rotating initially, that is the omega. Now calculate the final angular velocity of combination of disk. Okay, that is the question. Okay, I'm just, if you want to solve this, you can pause the video and you can attempt it. Okay, this is the time, but now I'm continuing, you will understand it. You can check your solution. Okay, now focus. There is what is happening. These are two disks. This is, suppose if I say disk 2. Okay, this is disk 2 and it's the axis of rotation and it is rotating about its axis with some angular velocity omega. It is given to you. Okay, now on this disk, if you see it, there is another disk. I am choosing the disk 1, I am placing over it. It's a second disk I am placing over it. This is disk 1. Disk 1. If you see it, this is disk 1 and I am placing over coaxially, same axis is there. Disk 1 and disk 2 having same axis, and its moment of inertia is I1, its moment of inertia is I2. Now we have to write, because we are putting gently, that means we are not giving any type of jerk or any type of torque to this system. The torque is not given to system, that means again we can say, because torque is equal to 0, then we can say angular momentum remains conserved. That means we can say angular momentum remains conserved or constant. And similarly, I can write from here that L initial must be equal to L final. What is L initial? Try to understand. Initially only disk 2 was rotating with the angular velocity omega, and what is the moment of inertia? I2. So what you will say? I2 into omega. But after some time later on, you will see both disks will move together because they are combined together, and when both disks will move together, that means their moment of inertia can be added, because this is a scalar quantity. I can say this is the I1 plus I2 multiplied by omega final. This is the final angular velocity we want to calculate. So what is the omega final? You will see it, I2 omega divided by I1 plus I2. Try to focus on this. You will understand that the final angular velocity. It is a final angular velocity. This is a very easy thing. You can solve it. Understood? But listen carefully. This question, I am telling you the few more things along with this question. Sometimes they ask this question in a different manner also. You have to focus. Suppose they will tell you if they are initially, the both disks are moving. Not only one disk is moving, both is moving. Suppose this is a disk 1. Okay, this is disk 1 if I say it, and it is also moving. Okay, and this is disk 2, it is also moving initially. This is disk 2. This question, now I am changing the question to try to focus, don't combine with the previous one, and its moment of inertia is I1, this is I2. Initially its angular velocity was omega 1, its angular velocity is omega 2. When this system is combined, both are moving in together. Finally, when both is moving together, the system would be like this. When they are moving together, so this would be omega final, and this is nothing else I1 plus I2. Okay, combined system. But initial same we can say, and here also the torque is equal to 0. That means initial angular momentum would be equal to the final angular momentum. I can say it very simple. L initial is equal to L final. What is the initial? You will say I1 omega 1 plus I2 omega 2. That would be equal to I1 plus I2 into omega final. So using this part, if you see it, that is equal to, from here we can define omega final is nothing else I1 omega 1. Just wait. You can check from here, that is the omega final is equal to beta I1 omega 1 plus I2 omega 2, okay, and divide by I1 plus I2. That also they both bodies are moving, both disk is moving, then we can solve like this way. So we have chosen very simple key, initially one disk is moving, we can understand disk 2 was moving initially, only disk 1 is at rest. Now we are placing together, now both will move together. So what is the final velocity? I can say initial angular momentum plus is equal to final angular momentum. Initial angular momentum I2 omega, final angular momentum I1 plus I2 into omega final. We can solve this type of problem. So we can see this problem. Now you can check your answers. Okay. Now we are moving to the next example. You will understand little more. Okay. So I am just reading the question. What is the actual language of the question? A thin circular ring of mass m radius r rotating about its axis with a constant angular velocity omega. There is a one circular ring is there of mass m radius r, good, and two objects each of mass small m are attached gently on the opposite ends of a diameter of a ring, okay, and calculate the final angular velocity. Again similar type of problem. Now you will find this type of problem also in the PYQ and different books, okay. So you can pause the video, you can attempt this question, okay, and start solving. You can check your answers later on. Now focus in this case. What is happening initially? There the one ring was there. If I say this is, suppose this one ring is there and it is rotating about its own axis. Its own axis, its ring, it's the ring. If it's, I say the what is the radius of this ring, that is the r, that is the small r, okay, I can put it small r, you can find this is small r and its mass is capital R, and initially it was having an angular velocity of omega, you can find it. So if I want to write what is the initial angular momentum, everyone can write, you will say initial angular momentum is nothing else I into omega. What is I? Ring is there, for ring, and what is the moment of inertia? That is equal to mr square. Just multiply with omega, that is the initial angular momentum. Very simple, we can write it. Now this is the first line of the question, we have to focus. Now second line, the two objects each of mass small m are attached gently on the opposite ends of the diameter. That means we can take from here, this was the ring, okay, and in this ring if you see, this is a ring, and on this ring if you are finding two masses, this mass small m and this is mass small m. Gently we are placing it. Okay, and they are diametrically opposite point. We have to understand. Okay, the ring mass is capital M and radius is small r. Now it will rotate with some omega final. Okay, now again the question you have to understand, both masses are placed gently. Gently means again we are not giving any jerk, that means we are not providing any torque. Again the torque is equal to 0. If torque is equal to 0, that means we can say L is constant, or we can say angular momentum remains conserved. If angular momentum remains conserved, that means very simply I can say L initial must be equal to L final. What was the L initial? We have already calculated that I into I means we can say mr square into omega, and what is the L final? So you can combine I you will write for this ring plus small masses. So what is the for ring? M in capital M into r square. For small m mass, one mass you will say small m into r square, but there are two masses, so I will put 2 also, and that is equal to omega final. Now from here we can write very simply omega final is equal to m into small r square into omega. From here you can say m plus 2 small m. I have taken the r square common. R square can be removed. That means omega final is nothing else capital M into omega divided by capital M plus 2 small m. This is the very basic thing we have solved this problem. Now try to understand what we have done. Initial angular momentum we have written, and initial angular momentum is nothing else. It is using the moment of inertia of the ring and multiplied by initial omega. After that we are placing some masses and we are putting gently. Be clear about this word. We are putting gently. Gently word is showing you that we are not giving any torque. We are not giving any torque. That means net angular momentum remain conserved. That means initial angular momentum must be equal to final angular momentum. That means from here I can say omega final is equal to m omega upon capital M plus 2 small m. This is again a very good question. You will find this type of problem also. This question can be asked in different manner also. Okay, I'll show you later on, we will understand. Now come to the next example. You will understand after this. Example 3. It is a little theoretical question I have given to you so that you can understand the concept of the angular momentum, conservation of angular momentum. A mass M moving with the constant velocity along a line parallel to x-axis away from origin, nice, and its angular momentum with respect to origin is 0, remain constant, goes on increasing, goes on decreasing. This type of question also you will see in the PYQs. That is also one of the finest question. Now try to understand. This will give you the very important concept about the angular momentum. Try to see, this is suppose x-axis I am choosing and this is a y-axis, and on this one point I am taking it. Suppose this is the one point is A, and from this point I am drawing another line that is parallel to the x-axis, and suppose this point coordinates are I am choosing suppose 0 comma A. This is 0 comma A, and because this is the origin, from origin I am taking it, this is the 0 comma A, this is the one line parallel to x-axis. Now focus on the board. You will understand one more thing. There is a one particle. Suppose this particle is here P, and it is moving away from the origin. This mass is m, velocity is v, it is given to you. Now the question is that what is happening with this angular momentum. So there are two things you have to focus when angular momentum we are writing, because it's a vector quantity. So there is the very first thing, what is the actually its magnitude, what is the direction. Then we have to understand one by one what is direction, what is the magnitude. So I will first focus on the direction. What is the direction of actually angular momentum would be. So try to understand wherever this particle it is, it does not matter on this line wherever it is. So suppose if I say this particle was started from A point, then it reaches to here, then it reaches to the P, then it reaches here, and it will, with the time, it is going on away from one by one. Okay, at any point of time, if you see, you will understand one thing very clearly from here. When particle was here, so you will join this. When particle is here, you will join this. This is R vector. Then when particle is here, you can see this is R vector. So these are R vector. Okay, but radius is always in this section. Okay, this is a radius whenever the particle is moving. Okay, now we have seen one thing, what is the angular momentum. So I told you R is nothing else, L is equal to m into R cross V. Now try to focus what is the meaning of R cross V. So first we are focusing on the direction only. So R cross V, we know from the cross product of vectors. Suppose if I take two vectors, A cross B is equal to C. What is the property of these vectors? You have to understand first. This C vector would always perpendicular to A, as well as C vector is always perpendicular to B. Very first thing you have to be clear about it. So from it, what we are understanding, whenever we are choosing any two vectors, A cross B, and their cross product is equal to C, then C must be perpendicular to A, C must be perpendicular to B. Now I am using this thing here. That means if L is equal to M R cross V, that means I can say L is also perpendicular to R and L is also perpendicular to V. This thing is must condition you have to obey. Now see it. This R vector is always lie in this plane. This is the R vector, I am choosing it. R, it is changing. R prime you can say, R double prime you can say, R triple prime you can say. These are different R vector. Velocity is constant, so I can say this is velocity vector. It is not going to change. This velocity remains same. This is the velocity R vector in this same plane. If both are in the same plane, so definitely L would be perpendicular to this plane at any cost. So whatever value of V, whatever value of R, but L would be perpendicular. Perpendicular with direction outward or inward. So we know very simple, R cross V cross product, we have used right and thumb rule. So R cross B, that is the actually invert this plane. That means from this observation we are understanding that angular momentum is inside the plane. Now one thing we have understood from this whole discussion, that angular momentum would be perpendicular to this plane and inside the plane, not outside the plane. Now focus. The second thing we want to know actually its magnitude. So what is the magnitude? I am just drawing this diagram again, you will focus. Suppose this is again x-axis, I will say this is y-axis, okay, and on this part you will see it, if I say the particle is moving on this line, okay, anywhere. So I can choose any point. Suppose this point was A and this point is, suppose after some time it will reach to B or it will reach to C or P, I can choose. So this point is, I am saying this is a 0 comma A point. I can choose this is a B point is there, that mass is M, and here velocity is V, that is parallel to this, okay, the mass is M. And now if you choose this vector R vector from here, if you choose this is R vector, okay, so now we have to write the angular momentum. Angular momentum is nothing else M R cross V. So we are not interested now in this direction we already know. So we are focusing on the magnitude. So we can say L is equal to M R into V into sine theta. Okay, try to understand M V R or R V into sine theta, or I can say L is equal to M V into R sine theta. I can write like this. R sine theta. What is this theta? Theta is the angle between R and V. This is the angle. If this angle is theta, then definitely this would be theta. and this is theta, that means r sin theta would be nothing else. From here, if you understand this part, you can see very clearly if this is nothing else r sin theta. This line would be r sin theta. And r sin theta is equal to a. So from here I can write very simply that L can be written as m v into a. That means that magnitude would be mva. Now you can see the particle is at B or at A or P, whatever condition. Now you can say very simply that this perpendicular distance between V and R would be only r sin theta, or that is equal to a. That with directly we can say mva is the angular momentum, and it is the outward or inward, so that is the inside the plane or inward. So from here we can say it is not zero, definitely it remains constant, definitely it is not increasing, not decreasing. So whenever this question comes to you, you have to focus. I am giving one question, similar type of problem you can try in your study time. That would be help you to understand a little more this concept. This is the x-axis, this is y-axis. Suppose one particle is going on this path. Similar question, okay, and that mass is m and this velocity is v. If you see, suppose this point is nothing else a comma 0. This point is nothing else 0 comma minus a. I am giving a very simple data. Try to find this angular momentum of the particle will change with the time, with the about origin, or it will increase or decrease or zero, or it remain constant. If it remain constant, what would the value? I am giving this question for you. You can try in your study time. Okay, this is the example 3. Now you can check your answers. Okay, now we are moving to the next problem. Okay. Another good question, you will find the density remained constant if the earth contract to the half of its present radius. Calculate the new duration of day. New duration means it's a day. Sometimes we call this line as a length of the day. New length of the day. Length of the day means right now we are having 24 hours for a length of day. So what will be the new length of the day if it is its radius becomes half, keeping the density constant. Keeping the density constant, definitely the few things will be changed. How it will change, we have to understand. So we are just contracting by keeping the present radius. So we are not changing any other thing. It is contracting by itself. Contracting by itself. So now you understand, whenever internal forces are there, due to internal forces, linear momentum does not change. Similarly, due to internal forces or due to them, the angular momentum also does not change. Because linear momentum is not changing, then angular momentum is also not going to change. If it is not going to change, that means angular momentum of this earth system will remain constant. It will remain same. It is not going to change. Now focus on this, you will understand. Suppose this is the earth initially and it was rotating. Okay, it was rotating about its own axis, we know this, and this angular velocity is omega, or we can say this time period is t. That means we already know that is equal to 24 hours. Okay, and its radius is nothing else, right now we can say r. Its mass we can write in terms of radius and density. I am writing its density is rho. So this is the first case we can see. Okay, so one thing you can write here. So if I ask you what is the mass, so you can say mass is nothing else a density into volume, and we can say density into volume. What is density? Rho. And what is the volume of this earth? Because earth is spherical in shape, you can understand it the sphere. So for this sphere we know the 4 by 3 pi r cube at the solid sphere. So for solid sphere we have to understand its moment of inertia also. So what is the moment of inertia? You can say 2 by 5 mr square. So I can write this very simple, that means 2 by 5 What is the mass? Mass is equal to density into 4 by 3 into pi r cube multiplied by r square. So I can just rearranging the term, you will understand that would be I is equal to 8 by 15 rho into pi into r to the power 5. That's the very basic. This is the very first thing we have to understand, and it was rotating with the omega. Now the second part we have to understand, now the radius become half. Everything is same, the radius become half. So this is the new earth. So this is again rotating about this own axis, you can see, and its radius become r by 2. Density again remains same, and now this would be omega final, and there would be some t final we have to calculate. Try to focus. Now again we want to write its mass. You will say mass is equal to rho into v. So this would be m prime. Definitely it is going to change. So you can say m prime would be density into volume. Volume is nothing else 4 by 3 pi again r by 2 whole cube, you can say. Here also you will say I prime, that is going to change. You will say m prime into r by 2 whole square into 2 by 5. When I solve it, I can say directly that is equal to 8 by 15, okay, that rho into pi r by 2 to the power 5. This is the second moment of inertia. So first moment of inertia we are understanding, second moment of inertia we are understanding. I told you here also the torque is equal to 0 because it's happening due to internal forces only, contract. So it is happening, that means torque 0, that means initial angular momentum is equal to final angular momentum. So what is the initial angular momentum? You will say I into omega, and that is equal to I prime into omega prime. We have to understand. Now put the value. I is nothing as 8 by 15 into rho into pi r to the power 5 into omega is nothing as 2 pi by t is equal to, what is the final angular velocity? Again you will say 8 by 15 into rho into pi r to by 2 to the power 5 and the omega final. I can write it. So from here you can see this constant power is going on, that would be r to the power 5 divided by t, that would be r to the power 5 divided by 2 to the power 5 into, I can say t prime I can write it. So r to the power 5 is also gone, that means t prime is nothing else t divided by 2 to the power 5. 2 to the power 5 means you can say 32, that means 24 hours divided by 32, that is equal to in hours. If you want to write in terms of minutes, you can directly say 24 into 60. Now you can see the 24 because hour means 60 minutes, my multiplying divide by 32. If you solve it from 8 this would be 4, from 8 this would be 3, and from 4 if you divide this 60 that would be 15. So that would be equal to t prime is equal to 45 minutes. 45 minutes, that means the new length of the day would be only 45 minutes, that is less than 1 hour. It is interesting, understanding. Right now we are having 24 hours day, this is only 45 minute day, okay. So if this earth is contracting, it is contracting due to internal forces. So what I want to say again, this is the one big earth is there initially, this is the original length of the earth, you can understand. So in this case you can find this, the earth is there, okay, and now it was radius, initial radius was r, now due to contact it become r by 2, the new length of day would be 45 minutes. Now you can check your answers, you will find. Now we are going to come next example, that is also one theoretical question, try to understand. This is the one good question. When a planet moves around the sun, then its angular velocity is constant, aerial velocity is constant, linear velocity is constant, linear momentum is conserved. Now we have to understand which is the correct answer, okay. That's the one of the finest question conceptually you have to understand. What is happening? If you see here, the planet is move around the sun. When planet is move around the sun, it is the elliptical path. It is not a circular path, it is the elliptical path, keeping the sun at one of their foci. So actually the path is like this of any planet. Okay, this is the path of any planet like this you will find, and there is the one focus is here and sun is present here. The planet is moving at any point. This is the planet. You can choose any planet, maybe Earth, maybe Mars. So this is the one planet. It is revolving around it. But it is revolving around due to one force, that is a very important force we call gravitation force. That is equal to gravitation force. And remember one thing, what I want to say, the gravitation force is the central force. Central force. Now try to understand the very important property about central force. If you understand this will help you to solve the many different questions. When we are talking about the central force means the force that acts along a line joining a fixed point towards it or away from the fixed point. Away from the fixed point. Try to understand what I want to say from here. The fixed point, that means it will act. Suppose there is a one fixed point is there. Suppose this is the point O. A particle is anywhere. It is moving on this path. Okay, try to see. Suppose particle is here at point A, or particle at point B, or particle at point C. Try to understand when it is at point A. At this point A, this is the, if I say force vector, this is the R vector is there. Okay, this is the R1, and force vector is supposed towards origin, towards this O vector. If I say this is the F, so when it reaches here, you will find this force would be again the towards same O vector only, towards O. Then only we can say this is central force. Now this is the R2, I can say this is the F prime, this is the F. Like this, maybe force is changing, but its direction would be always towards this fixed point only. If it reaches to the C point, the suppose particle reaching to the C point, you will understand again this force will towards only center, that means towards O only. Maybe this radius vector would be something different, it will be R3. Force may be different, the magnitude may be different, direction may be different, but the one thing is fixed here, what is that direction is towards the same point or away from same point. It may be outside also, equally true. So this is happening, then we call it central force. Here also the gravitation force is the central force, because it is always act toward the sun. Suppose this particle is here, this planet A point. If planet reaches to this point B, again the gravitation force is towards sun. If this planet is reaching to C point, then you will find again this is the gravitation force toward the sun only. So it is also central force. If central force, now you can understand very important property we call torque, and torque is nothing else R cross F. Now see, the R and F both are just opposite. That means angle between them, that is equal to 180 degree. If force is outside, that would be 0. In both cases you can find R and F, either they are 0, either 180 degree. In both cases R cross F would be 0. It is a fixed thing. We can say torque is equal to 0 for central forces. So central force, the torque is 0. That means again angular momentum remains conserved. If angular momentum remains conserved, that means I can say very simple thing, that here angular velocity is not constant. Now you will say why not constant? Because I is changing. Now the linear velocity is also not constant? Because angular momentum is constant. If r will change, it will change, because L is nothing else mvr. If r is going to change, v will also change. Okay, and this is nothing as v into r, that is equal to, we are multiplying, it will be c. If r is going to increase, v is decreasing. If r is going to decrease, v is increasing. We will see that also. Next, linear momentum is conserved? Definitely not, because there the force is acting. Due to that, the velocity is changing. Velocity will change, v is changing, then linear momentum also changes. Now try to understand what we are saying, v and r. This v and r, if I'm just giving one extra information, you can understand what is happening there. One very basic thing. There are 2 points I'm just choosing. This is the first point. If you choose this here, this point, and this is another point. We call this is the nearby sun, we call perihelion. This is the away from the sun, that is equal to aphelion. On this position, because this r is minimum, you can see it that the r minimum we call rp. This is away from the sun, very far away distance, we call ra, that's the aphelion. So this is the apogee and perigee, these are 2 distances, you can see it. So one thing we can say, L is equal to m into rp into vp is equal to, similarly I can apply here also, that means m into ra into va, and this m can be removed from both sides. So here the radius, you can say this is minimum, the distance is minimum, then velocity would be maximum. Similarly, if here the radius is, this distance is maximum, then velocity would be minimum. That means here the velocity is aphelion is the minimum value, and perihelion this would be maximum value. So the Vp is maximum value and Va is the minimum value. That we will understand this topic. Okay. Now one more thing is remaining. What is the aerial velocity? How we can understand what is the aerial velocity? So for aerial velocity, we can take a very small portion of this part. Okay, I'm just taking the very small portion here. So you will understand, suppose this distance is nothing else, very small distance, that the r here to here. Okay, this is just like a one triangle, I can choose it, and if I want to say this is velocity is v and this distance is dt, so I can choose dt. Very simple. So this time interval here is delta t or dt. Okay, this is this small distance delta t. So here to here distance would be v into delta t. So I can write this thing in a different color. You will understand this length is nothing else, v into delta t, and this distance is approximately r. It is also approximately r. So if I want to write what is the area of that triangle, we have assumed, if I write area, you will say approximately 1 by 2. Okay, this is a triangle, 1 by 2 base into height, so I can say that is equal to v into delta t into r. So from here you know 1 by 2 v into r into delta t. Delta t is nothing else, again we are putting the constant value, that is the constant. Okay, for small r, so I can say area is delta A divided by delta T, that would be 1 by 2 V into R. Focus, delta V by delta T, this is nothing else aerial velocity. What we call it? Aerial velocity. This we call aerial velocity. You will understand, and this is 1 by 2 V into R. Just see this 1 by 2 V into R, that is also very important. We can choose from here V R is equal to L by M. This value can be placed here. You can say 1 by 2 into L by M, or we can say dA by dt is equal to L by 2M. L is constant, mass is constant, that means this is also constant. So we have to understand this is nothing else, Kepler's second law. In gravitation topic we will understand this is Kepler's second law. That means angular velocity, this aerial velocity in this planetary motion, you will find that is equal to constant, that is not going to change. You have to understand, and I have actually summarized this. Is here 3 things you have to learn one by one. Very first thing, gravitation force is the central force. What is the meaning of central force? You have to understand that the force that act along a line joining a fixed point towards it or away from this fixed point. And due to central force, any kind of central force, it may be gravitation, it may be electrostatic, it does not matter, okay, or there is a spring force, or in any kind of force, you will understand these are central force, and due to central force always torque is equal to 0. If torque is 0, angular momentum remain conserved. I am giving one simple conceptual question for you. Try to think about it in your study time, you will understand. If central force is there, particle motion will be confined to the same plane or out of the plane is possible. Listen, if only central force is acting on a particle, its motion is remain confined to the plane or out of the plane is possible. That is one question for you. Try to think and you can comment on the comment section. We will talk about it. Okay, and the aerial velocity here remain constant, that dA by dt is equal to L by 2m. L is constant, that means aerial velocity is constant. So this thing we have to understand. Okay, now we can move to the next question. Now come to the next problem, that a particle undergoes a uniform circular motion, about which point the plane of the circle will the angular momentum of particle remain conserved. It's a good question and you have to understand, you have to think. You can pause the video, you can see it. Okay, what will be the possible answer about the center of the circle, on the circumference of the circle, inside the circle other than center, or outside the circle. So try to see and just try to solve. Now focus on the board if you want to see it. The very first thing is the circle is there, particle is moving on a uniform circle. This is circle, this radius is r, and I am choosing this point, and you will see here this is the center O point. If particle is moving, this mass is m, it is moving with the uniform circular motion, that means this velocity would be constant, that the v speed is constant, not velocity, speed is constant here. So now you can see whenever the particle is any point, this r will be same, this r value would be same. If r is same, the speed is also same, r is same, and all point is perpendicular, all v and r are perpendicular. So from here we can directly say that the angular momentum would be m into v into r. Directly I can write, and because all points are perpendicular, so directly this value is m into v into r, that's the constant value. Now we talk about its direction also you can say, because r and v both are in same plane, so the angular momentum would be perpendicular to this plane. We have just discussed in the previous question, you will understand that angular momentum would be perpendicular to r and v plane. R is outward, v is this plane, so r cross v. If by using the right hand thumb rule, you will find the angular momentum is outward the plane. This is a very simple thing, you can understand. This is the angular momentum we are talking about. So about center it is a constant that is not going to change. So I can say this first part is correct. But it is possible that on the circumference, so we will talk about the second possibility also. Suppose this is the one circle is there. Okay, on this circle you will find that suppose I am choosing one point, this point is there, and about A we will talk about. So when particle is at different point, okay, particle is here or here or here, you will find any point. So from here to here you join r vector. R is changing continuously. If R is changing continuously, V is same, M is same, definitely angular momentum is not constant. It is not constant here. That means second is not possible. Inside the circle other than center, I can choose any other point also. You can see, I am just drawing again this diagram. You will see this is the one circle is there, and I am taking one point here. Suppose this is the one point other than center. I am taking this point, suppose A, and this is center. We know this O. So particle is here, over here, or here. Different point you can find it. So every point, this is just, you can find this distance or this distance. Every distance is going to changes here. Here also distance is changing. Definitely we cannot say the angular momentum remain conserved here. That is also, sorry, linear momentum remain angular momentum is this point about also not constant, because the r is changing, v is constant here. Now outside the circle, that is also possibility we have to understand. Suppose this is again circle is there and I am choosing one point here, this is a P, and particle is here or any point is above this circle. If you see the above this circle, this is a very interesting case. Now try to see the particle is here. If I joining this r vector or I join this point or join this point, you will find this is another, all points or are different points, okay, and velocity is above direction like this. This is the case. In this cases, if you see the r cross v, if r cross v, you will find that the outward this plane, out of the plane, if you are understanding, but again the r is continuously changing, v is constant. So again this is also not possible answer. But if you see the downward side, the velocity is here, r vector is here, okay. So what is the r cross v? You will see that the inward, here the outward, the angular momentum here the inward. By the way, that is not constant, so it is also not possible answer, but you have to see the direction is also changing. In other part direction remain constant, in this part direction is changing, you have to consider it. That is also one good question to understand the concept of the conservation of angular momentum. Now we are moving to the next topic, you will understand. Next question, it's the one good question, again a one PYQ. You can see one ballet dancer spins about the vertical axis, okay, not a vertical, it is a vertical, you can take a space, and axis at 60 rpm with her arms closed. Now she stretches her arm such that the moment of inertia increases by 50%. Calculate the new speed of revolution. Very simple. Suppose we take a one ballet dancer is here, okay, I cannot make a good art to try to compromise with that, okay. So try to focus on this. This is the one ballet dancer, and initially she spins vertical axis rpm, their arms were closed. These are taking arms like this, arms is closed, and she is having rotating about this axis. So she is rotating, and that axis omega is also giving to you, that is the omega. How much omega is given? That is equal to 60 rpm. 60 rpm. She was actually rotating. And suppose if I assume this is the moment of inertia is nothing else, I initially. Now in the next case, she is going to stretch her arms, okay, this is again, okay, she is stretching her arms like this, and what is happening, this is a ballet dancer, again you will see what is happening, this is new angular velocity, that is the omega final. So in this case, initial angular velocity, final angular velocity, we can check it. Again here moment of inertia is also going to change. How much this become? I prime, it is increased by 50%. Suppose initial was I, now I is increased by 50%. So what I can say, I into 150%. So to remove the percentage, we have to divide by 100. We can check it, or I can say I prime is nothing else 1.5 I. This is happening. Now we have to calculate omega final. Just do the same thing, conservation of angular momentum. Now you are habitual to that part because no external torque is applied. So directly you can say L is constant, or we can say L initial is equal to L final. What is that? I into 60 rpm omega is equal to 1.5 I into omega final. I can be removed, and what is the omega final? You will say 60 divided by 1.5. If point will be removed, you will solve it, that is equal to 40. That means final angular velocity would be 40 rpm. So what we are understanding from here, if I will increase, the omega will decrease. I will increase, then omega will decrease. That is a very basic concept. I am giving one question here, try to understand. Suppose one rod is there, it is rotating about its own axis. If temperature is going to increase, what will be the effect on its angular velocity? That's the question for you. Try to listen again. This is the one rod, it is rotating about its own axis, about mid position, okay, and if temperature of this rod is going to increase, what will be the effect on its angular velocity? That is the again conceptual question. Try to focus and try to solve in your study time. Okay. Now, one more question we are going to see. You will understand that the next question, the disk of mass 100 gram and radius 10 centimeter has a projection on its circumference. The mass of projection is negligible. A 20 gram bit of putty moving tangential to the disk and at the velocity of 5 meter per second strike and the projection and stick to it and calculate the new angular velocity of the disk. Again, this is one PYQ. Try to focus. Suppose this is the one disk is there, okay, and it's the outer line we are saying this is equal to its projection at the center, okay, and one putty is coming, that the tangential to this part, it is coming, it's a 20 gram putty, and the mass of this disk is given to you, that is equal to 100 gram, and radius of the disk is given to you again, that is equal to 10 centimeter. Okay, now try to understand. Initial velocity is 5 meter per second. 5 meter per second. Try to focus. So we can convert this centimeter into meter, that would be 0.1 meter. I can say it. These are few values, you have to focus first. So initially this putty is coming and it stick to this disk, then the disk start to rotate. Disk will start to rotate, they will move together, and then we have to solve this question. How to solve this question? Focus on this part. You will focus. The very first thing, initial angular momentum is equal to final angular momentum. I can apply again because there is no external torque is there, just the putty is coming and just stick to it. Initial angular momentum would be how much? So this is coming, this mass is coming. So I am writing this mass is suppose is small m. I am saying this is a capital M mass, this velocity is v, and radius I am writing suppose this is the r. So you can say small m into v into r. After that this it will stick to this capital M. So you can say this is a disk. So there would be moment of inertia capital M r square by 2 plus this putty moment of inertia small m into r square into omega. Now my concern is very simple, how to calculate this omega. So from here you can write that omega is nothing else m into v into r. From here one r can be taken common, or r square can be taken common, r square, that would be equal to capital M by 2 into small m. One r can be cancelled. Now put the values, you can understand. What is the small m? Small m is nothing else 20 gram. 20 gram velocity is equal to 5 meter per second. R is equal to 0.1 meter, and capital M is nothing else 100 gram. So 100 gram by 2 plus 20 gram. I can write it. So just try to solve it. That would be 20 gram into 5 meter per second divided by 0.1 multiplied by this would be 50 plus 20, that would be 70 gram. Gram can be cancelled. From 0 this point can be removed, that would be 100 by 7, this would be omega, that radian per second. I can write it, that is the omega. Very simple, you can use it. This is the new angular velocity of the system. Okay, that is the one question. I am giving similar type of problem for you. You can try in your study hour. Okay, suppose there is the one rod is hanging about this point. This is a mass m, length is l, and one again I can say this is one putty is coming. This mass is small m, velocity is v naught, and again this stick to it, and after that it will start rotating. Again you have to calculate the final angular velocity. I am saying this rod is hanging, mass m, capital M, length l, and one putty is coming of mass small m and velocity v naught. then they will move together of the system. What is the angular velocity? That is the another question to you. Okay, so I think it would be sufficient for you. So I'm keeping class up to here. If any doubt is there, you can put your doubts, your answers in the comment section. I will wait for that. Thank you so much.